If compound consists of 6 carbon atoms, then the root word should be used here is hex. What are hydrocarbons? Compounds made up of only carbon and hydrogen atoms are called as hydrocarbons. Hydrocarbons are classified based on the type of carbon-carbon bonds, whether it is a single bond, double bond or a triple bond. Alkane in the form of ring structure or a closed structure is called as cycloalkanes. Hello dear students, I am Roja, your chemistry lecturer from Vidhyaashram PU College, the Temple of Excellence, Mysuru. So today we are going to start a new chapter, hydrocarbons. So in this chapter, we are going to study about hydrocarbons, their classification, physical properties and chemical properties. Today's session, we are going to study about what are hydrocarbons, the uses of hydrocarbons, then classification of hydrocarbons. In that, we are going to study about only alkanes. So, nomenclature and isomerism in alkanes, the preparation of alkanes and their physical properties of alkanes. So, what are hydrocarbons? Compounds made up of only carbon and hydrogen atoms are called as hydrocarbons. And what are the importance of hydrocarbons are? It is used as fuels, for example, LPG, CNG, LNG and petroleum products, that is petrol, diesel and kerosene, which are obtained from fractional distillation of petroleum products, coal gas and natural gas. So, LPG we know it is used as a domestic fuel which is of least pollution. CNG is compressed natural gas which is used in the automobile as a fuel. That also is of less pollution. LNG is liquefied natural gas. It is obtained by liquefying natural gas. Petrol, diesel, kerosene and all, it is obtained by fractional distillation. Coal gas is obtained from destructive distillation of coal. Then natural gas is found during oil drilling. The other uses are, it is used in the manufacture of polymers, for example, polythene, polypropylene, polystyrene. And it is also used as a solvent in paints. And they are also used as a starting materials for dyes and drugs. So, let us study about classification of hydrocarbons. So, hydrocarbons are classified based on the type of carbon-carbon bonds, whether it is a single bond, double bond or a triple bond. So, classification includes saturated hydrocarbon and unsaturated hydrocarbon. So, saturated hydrocarbons are of alkenes. It means it consists of carbon-carbon single bond. And alkenes are those which consist of open chain. That means it's a straight chain or open chain. Example is CH4 or C2H6 and it goes on. So, the first member of alkane is methane, that is CH4, and it goes on with a single bond, carbon-carbon single bond. So, methane consists of 1 carbon atom and 4 hydrogen atom, that is single bond. And the second is ethane, consisting of 2 carbon atoms with single bond and remaining hydrogen bonds. Then this is of propane, consisting of 3 carbon atoms, again with a carbon-carbon single bond and satisfying the tetravalency of the carbon. Another type of saturated hydrocarbon is cycloalkane. Alkane in the form of ring structure or a closed structure is called as cycloalkanes. So, for example, cyclohexane. Hexane in the sense it consists of 6 carbon atoms with carbon-carbon single bond. But when it is in a loop structure or a ring structure, the structure of the carbon will be this. So, it is all the ends of the carbon are being connected to each other. So, it gives a ring structure. So, the other form of writing the structure is this one. So, carbon 1, 2, 3, 4, 5 and 6. So, 6 carbons are attached to each other and followed by the tetravalency of the carbon, hydrogens are attached to all 6 carbon atoms with a single bond. So, other type of hydrocarbon is unsaturated hydrocarbons. So, these type of hydrocarbons consist of carbon-carbon double bond and also carbon-carbon triple bond. Under this, we have 3 types of unsaturated hydrocarbons. That is, first one is alkenes. It is alkenes. Alkenes are those compounds which consist of carbon-carbon double bond, or it can be 1 or more double bonds in a compound. For example, ethene, that is C2H4. So, there is a double bond between these 2 carbon atoms followed by the satisfying of tetravalency of the carbon. So, there is a double bond between carbon and carbon. So, this type of compounds belongs to alkenes. The other type is alkynes. It consists of a compounds which consists of carbon-carbon triple bond. So for example, ethine. So that is triple bond between two carbon atoms, and tetravalency of the carbon is also satisfied here, forming a group ethine, C2H2. So there are other compounds which consist of both double bond and a triple bond in a single compound as well. The other type of unsaturated hydrocarbon is aromatic hydrocarbons. This is a special type of cyclic hydrocarbon with delocalized pi electrons. So in this aromatic hydrocarbon, it consists of a ring structure, but it consists of double bond or a triple bond. Example is given benzene. Benzene consists of alternate double bonds in the structure, which is having a delocalized pi electrons in the ring structure. And followed by benzene, there is one more structure called toluene. Benzene connected to methyl group is called as toluene. Now let us study the classification of hydrocarbons one by one. Under that saturated hydrocarbon, we have alkanes. So let us know more about alkanes. Alkanes are the saturated hydrocarbons or open chain hydrocarbons consisting of only carbon-carbon single bonds. So the old name of alkanes is paraffins, meaning little affinity. The name paraffin is given because they are chemically inert under normal conditions. That means they do not react with acids, bases, reducing agent or oxidizing agents, etc. The first member of alkane is methane, that is having a formula CH4. So therefore, the general formula for the alkane is CnH2n plus 2. This N represents number of carbon atoms. So if compound is having one carbon, that is single carbon, the formula is C1H2 plus 2 is 4. Therefore, the molecule is again a methane, that is CH4, and it goes on depending on the number of the carbon atom, it goes on. So how will be the formation of higher alkanes? So since we know that it is the first member of the alkane group is methane, from methane one hydrogen is been replaced by another methyl group to give higher alkanes. So the next, after methane, the next member is ethane, that is C2H6. Continuing this replacement, that is replacing of hydrogen by the methyl groups, so you can get the other higher alkanes such as propane, butane, pentane, hexane, and goes on. That is about alkanes or the formation of higher alkanes. Now we shall learn about alkyl groups also. What are these alkyl groups are? So it is formed by removing of one hydrogen atom from an alkane. Here no replacement of any other alkyl groups to form a higher alkane. It's just a removal of one hydrogen atom from the given alkane group. So the general formula of alkyl group is CnH2n plus 1. That means one hydrogen atom is removed. Therefore, from methane, that is CH4, if one hydrogen atom is removed from CH4, you can get the CH3 methyl group, and the name methane, from methane ANE is replaced by YL. So that is ANE is replaced by YL, giving a name methyl. Similarly, from ethane, that is C2H6, one hydrogen has been removed, forming C2H5, and the name ethane ANE is replaced by YL, giving a name ethyl. And similarly, for other higher alkanes also, it is applied the same rule. Let us now study about name, formula and structures of first 10 members of the alkane groups. So based on the number of carbon atoms present in the compound, there is a root word and the structure and what is the actual molecular formula for the given structure. So if there is only one carbon atom, the root word would be meth, M-E-T-H, and the structure is CH4, and therefore if alkane groups are there, then the name ends with the suffix, that is ANE. So meth word is the root word having a suffix ANE, forming a name methane, and the molecular formula is CH4. Suppose it consists of two carbon atoms, the root word is ETH, then and the structure is CH3 and CH3. So that is from methane group, one hydrogen has been replaced by another methyl group. So forming a higher alkane from methane, that is ethane, giving a formula C2H6. So that is the molecular formula for ethane. Now for the compounds consisting of three carbon atoms has a root word prop. So there are 3 carbon atoms satisfying the tetravalency of the carbon, and following the alkane's general formula, that is CnH2n plus 2, it has formed a structure CH3CH2CH3 and the name is propane, and total molecular formula is C3H8. If compound consists of 4 carbon atoms, then the root word is but and the structure is as such, and the name of the compound will be butane, having a general formula C4H10. If compound consists of 5 carbon atoms, then the root word would be pent, having a structure as such, and it is being compressed and given in a enclosed within a bracket, writing the number of carbon atoms outside it, therefore giving the name pentane and having a formula C5H12. So if carbon consists of 7 carbon atoms, then the structure goes like this: CH3, CH2 5 times and CH3. Totally it makes up to 7 carbon atoms, and the name is heptane and the formula is C7H16. If compound consists of 8 carbon atoms and the structure is like this: CH3, CH2 6 times and CH3, name is octane and the formula is C8H18. If compound consists of 9 carbon atoms and the root word should be used as non, CH3, CH2 7 times and CH3 is a structure and the name is nonane and the formula is C9H20. If compound consists of 10 carbon atoms, then it would be dec as a root word should be used here. Then the structure is CH3, CH2 8 times and then CH3. And therefore, the name is decane, having a formula C10H22. So, all these are based on the general formula, that is CnH2n plus 2. So, let us see now the nomenclature and isomerism of alkanes. So, nomenclature is both IUPAC and common names are listed out here. So, we shall see one by one. So, for CH4 structure, the common name that we use is methane, and IUPAC also is using the same name, methane. And for the ethane, that consists of 2 carbon atoms having 6 hydrogen atoms, common name and IUPAC name are both same, that is ethane and ethane. Similarly, for propane, there are 3 carbon atoms with 8 hydrogen atoms, and therefore the name, common name and IUPAC name is propane. So, when it comes to butane having C4H10, the normal structure is CH3, CH2, CH2, CH3. The common name for this structure is N-butane, meaning it's a straight chain, so it is N-butane. But for the IUPAC, it's normal butane. There is no N word or any other prefix given to that name, so it's just simple butane. And what if the butane structure is rearranged? That means the carbon atom is rearranged in structure, but the number of carbon atoms and hydrogen atoms are same. That meaning to say, molecular formula of this structure is same, that is C4H10. So, such type of compounds, meaning having the same molecular formula but different structural arrangement, such type of compounds are called as isomers, and the phenomenon is called as isomerism. So, butane can be written and rearranged in this manner also, that is CH3, CH, CH3. For this main carbon chain, methyl group is attached to second carbon, forming a formula C4H10. For this, a common name is isobutane. Iso in the sense it is branched structure. N in the sense it is straight structure. And the IUPAC name for this structure is 2-methylpropane. 2-methylpropane is because methyl group is attached to second carbon atom. So, if I start here 1, 2, 3. So, the second carbon is attached to the methyl group, giving a name that is 2-methylpropane. Propane is because main carbon chain consists of 3 carbon. So, it is 2-methylpropane. Now, let us see the next higher alkane, that is CH3, CH2, CH2, CH2 and CH3, that is of C5H12. So, since it is a straight chain, the common name is given N-pentane and the IUPAC is simple pentane. But what if it is arranged in a different manner? If the methyl group is attached to some other carbon chain of a longest carbon chain, then let us see how the name is given according to IUPAC. So this methyl, one of the methyl groups is attached to the second carbon chain. We'll see 1, 2, 3, 4. We'll number the carbon chain as 1, 2, 3, 4. Since methyl group is attached to second carbon of the longest chain, so it is 2-methyl, and butane is given because the longest chain consists of 4 carbon atoms. So therefore the IUPAC name is 2-methyl butane, and common name is, it is isopentane. Iso meaning its structure is branched. Now this pentane has got 2 other different structures also, having a same molecular formula, that is C5H12. Then what is the other structure is, the other methyl group, there are 2 methyl groups that is attached to the same carbon atom or of a second carbon atom. So if this is considered as a main chain that is consisting of 3 carbon atoms here, then there are 2 methyl groups that is attached to second carbon atom. The common name for such structure is neopentane, and the IUPAC name is 2,2-dimethyl propane. So let us see what are the types of isomerism. That is, structural isomerism are those isomerism which consists of same molecular formula but differs in the structures of compounds. In that, chain isomerism is one of those which has similar molecular formula but differs in the arrangement of the carbon atoms in the compound. For example, butane and isobutane are the isomers or a chain isomers that follows the chain isomerism. And also similar kind is pentane and isopentane. See, butane is of 4 carbon atoms. So this is a straight chain butane. For isobutane, one of the methyl group is branched to the main carbon chain. So the structure goes like this. So this is butane and this one is isobutane. Isobutane in the sense it is a structure is different and it's basically branched structure. Similarly for the pentane, so this is a pentane having a straight chain, and for the isopentane consisting of the same molecular formula, one of the methyl group will be branched. So for the isopentane, the structure will be different, that is one of the methyl group will be branched to the main carbon chain. So the structure is so this is isopentane. So that is about the chain isomerism. So there are types of carbon atoms in alkanes depending upon the carbon atoms that is attached to the other carbon atoms. Say for example, the first one is primary carbon atom. So the primary carbon atom in the sense, the carbon atom that is attached to one or no other carbon atom. For example, CH4, in this it is not attached to any other carbon atom. So it is called as primary carbon atom. Here in the second example, that is ethane, either this can be called as primary or this can be called as primary carbon atom. So if you consider this carbon as a main one, it is attached to only one carbon atom. So it is known as primary carbon atom. Here in this propane, there are 3 carbon atoms. So if you consider only this carbon atom, then it is called as primary. This is attached to one carbon atom. If you consider this as a primary carbon atom, here also you can observe it is attached to only one carbon atom. So either this or this can be called as primary carbon atoms. And in secondary, this carbon atom will attach to 2 other carbon atoms. For example, in the propane, the middle carbon atom is attached to 2 other carbon atoms. So it is called as secondary carbon atom. And in the tertiary, the carbon atom will be attached to 3 other carbon atoms. So this middle carbon atom is attached to 3 other carbon atoms. So it is known as tertiary carbon. Similarly for the quaternary, the carbon atoms will attach to 4 different carbon atoms. So for example, this middle carbon is attached to all 4 different carbon atoms. So it is known as quaternary carbon atoms. So what are the rules to be followed is, First thing is the longest chain of the carbon atoms corresponding to the parent alkane is to be written. Then after numbering it, the substituents are attached to the correct carbon atoms, and finally valence of each carbon atom is satisfied by putting the correct number of hydrogen atoms. For example, 3-ethyl 2,2 dimethyl pentane is the name given. If you have to draw the structure, you have to identify which is the parent chain, and you have to identify which are the substituents and at what position you have to give the substituents in a longest chain. So draw the chain of 5 carbon atoms because it is of pentane, and then the second thing is you have to give the numbers. Soon after giving the numbers, you have to find the alkyl groups or the substituents that is to be attached to the main carbon chain. So attach ethyl group at carbon 3 and 2 methyl groups at carbon 2 because the IUPAC name given is 3-ethyl 2,2 dimethyl pentane. So at position 3, you have to attach ethyl group, that is C2H5, and 2 methyl groups because dimethyl is given at the same carbon, that is second position. 2 methyl groups are to be attached to it. Now after doing it, satisfy the valence of each carbon atom by putting requisite number of hydrogen atoms. So following the tetravalency of the carbon atom, you have to fill the hydrogen atom. So for this first carbon, it is 3 hydrogen atom, then no hydrogen here. For the third one, it is 1. For the fourth one is 2, and the fifth one is 3. This is the complete structure for the given IUPAC name, that is 3-ethyl 2,2 dimethyl pentane. So now let us move on to the topic, that is preparation of alkanes. So how are alkanes prepared? So there are many other ways to prepare the alkanes. So let us study one by one. So from unsaturated hydrocarbons, so this process involves dihydrogen gas adds to alkenes. Alkenes are coming under the group unsaturated hydrocarbons, and alkynes also, in the presence of catalysts like platinum, palladium or nickel to form alkenes, and this process is called as hydrogenation, meaning hydrogen is going to be added to unsaturated hydrocarbons in the presence of catalyst. So this metal absorb hydrogen gas on their surface and activate the hydrogen-hydrogen bond. So this hydrogen-hydrogen bond will be broken down because of the catalyst. Then platinum and palladium catalyze the reaction at the room temperature, but relatively high temperature is required for the nickel catalyst to perform this process. So example, ethene is considered as an example to convert it into alkane. So when hydrogen is reacting with the alkene, that is ethene, in the presence of platinum, palladium and nickel catalyst, it gives ethane. Hydrogen will break the bond between this carbon-carbon double bond and takes place this position forming an alkane. Similarly for the propene, so there is a double bond between the first and the second carbon atom. So that is broken down by this hydrogen and hydrogen atom in the presence of platinum, palladium and nickel catalyst to give propane, corresponding alkane. And what if it is alkyne group, meaning consisting of carbon-carbon triple bond? This carbon-carbon triple bond is broken down by the hydrogen molecule, then in the presence of the catalyst forming corresponding alkane, that is propane. So the second way of preparing is from alkyl halides. So halogens that is attached to alkyl group is called as alkyl halides. Except for fluorides, other alkyl halides can be used. On reduction with zinc and dilute hydrochloric acid, it gives alkane. For example, it is chloromethane. So except for fluorine, anything can be taken for halogens. Chloromethane, when it reacts with hydrogen, that means it undergoes reduction process in the presence of zinc catalyst. It gives methane plus hydrochloric acid. The second example is chloroethane, that is C2H5Cl. On reduction with hydrogen in the presence of zinc and hydrochloric acid, it gives ethane, corresponding ethane or alkane, along with that hydrochloric acid. Then chloropropane, on reduction with zinc and the hydrochloric acid, it gives corresponding propane and then hydrochloric acid as a byproduct. The other way of using alkyl halides to prepare alkane is through Wood's reaction. This reaction is called as Wood's reaction, meaning alkyl halides react with metallic sodium in the presence of dry ether. It is used as a solvent here. Forms higher alkanes. It is used for the preparation of higher alkanes containing even number of carbon atoms. So, it forms a higher alkanes. Let us see with an example. Here bromomethane is taken as an example, that is 2 molecules of bromomethane that is going to react with metallic sodium in the presence of dry ether. It gives ethane. This ethane consists of even number of carbon atoms. Along with ethane, it gives sodium bromide. Similarly, for bromoethane, that means 2 molecules of bromoethane reacting with metallic sodium in the presence of dry ether, it gives N-butane consisting of even number of carbon atoms, along with that sodium bromide. So, the third way of preparing alkane is by using carboxylic acid. Sodium salts of carboxylic acids on heating with soda lime. Soda lime is a mixture of sodium hydroxide and calcium oxide. It gives alkenes containing 1 carbon atom less than the carboxylic acid. This process of elimination of carbon dioxide is called as decarboxylation process. So, let us see with an example. So, this is sodium salt of carboxylic acid, in the sense it is sodium ethanoate. The compound name is sodium ethanoate. So, when it undergoes reaction with soda lime, a mixture of sodium hydroxide and calcium oxide, on heating with this, it gives alkane, methane, that is methane, 1 carbon atom less than the actual carboxylic acid group. So, there are 2 carbon atoms here in the sodium ethanoate. When it forms an alkane group, it consists of only 1. Along with methane, it gives sodium carbonate. So, using carboxylic acid, there is one more method, that is Kolbe's electrolytic method. This process involves an aqueous solution of sodium or potassium salts of carboxylic acid on electrolysis gives alkane containing even number of carbon atoms at the anode. So, a reaction is sodium ethanoate is taken as an example, that is sodium salt. Along with that, when it undergoes electrolysis process, it gives ethane molecule, that is at anode, along with the carbon dioxide that also is being formed at anode. During electrolysis process, it also produces sodium hydroxide and hydrogen at the cathode. So, reaction mechanism involves this sodium ethanoate will dissociate to give ions, that is CH3COO minus and Na plus. So, during electrolysis process at anode, this acetate ion will lose 2 electrons to give free radical of acetate ion, and 2 molecules of acetate ion will dissociate to give one of the methyl group, and then carbon dioxide is released. Along with that, since there are 2 free radicals of methyl group, that is when it is going to react with each other, it forms a couple, like it forms CH3 bond CH3. So, that is why it is called as recoupling and giving a compound ethane. And at cathode, this water will lose 2 electrons to form OH minus and hydrogen gas. So, that was about how to prepare alkanes using some other compounds. Now, let us see physical properties of alkanes. So, in that polarity, alkanes are non-polar molecules because of carbon-carbon single bond and carbon-hydrogen bond. They are covalent in nature, and also due to low electronegativities between carbon and hydrogen are very close, the polarity is non-polar in nature. Therefore, they have only weak van der Waals forces between hydrogen and the carbon. So, the next physical property is about state at room temperature. So, at room temperature, what will be the state of alkenes? So, from C1 to C4, that is methane, ethane, propane and butane, they exist in a gaseous state. From pentane to heptadecane, it is in a liquid nature. C18 and above, it exists in a solid nature. So, it is called as paraffin wax. So, carbon 18 and above are called as paraffin wax. What about the color and the odor of alkenes are? Alkenes are colorless and odorless. So, the fourth property is solubility. In water, these alkenes are not going to dissolve in it. So, they are insoluble because they are of non-polar components and water is of polar component. So in non-polar solvents like petrol, benzene and ether, these alkanes are able to be soluble. So this follows the nature of like dissolves like rule applies here. Example, petrol, it's a mixture of alkanes. This is going to dissolve in a grease which is of a non-polar in nature, and that is why petrol is used in dry cleaning. So the other property is boiling points. Boiling point increases with atomic and molecular mass, because more the surface area, stronger will be the van der Waals force. And straight chain alkenes will have higher boiling point, branched chain alkanes will have lower boiling point. That is again because of the smaller surface area. Examples are isomeric alkanes. For example, here taken is isomers of pentane. Pentane, if it is in a straight chain, the boiling point will be more compared to other isomeric structure, that is 309.1 Kelvin. The isomer of pentane is 2-methyl butane having a temperature 301 Kelvin. The other isomeric structure of pentane is 2,2 dimethyl propane, has a boiling point 282.5 Kelvin. Comparatively, the straight chain alkane will have higher boiling point. So this was about physical properties of alkanes, and in the next session we shall study about chemical properties of alkanes and conformations of alkanes. Thank you.